Welcome back, everyone. Thanks for sticking around after lunch for the second leg of the conference. I have the pleasure now to have or to introduce Albert Lewandowski, who is based in Poland and is a DevOps engineer at Getting Data. He will be sharing his know-how about deploying and running Apache NiFi data pipelines on Kubernetes. And this will be a live talk. Albert will be taking questions at the end. So please drop any questions you have along the way in the Q&A tab, and he will get to it once he finishes his talk. Take it away, Albert.
Yeah, thank you for the introduction. Hello, everyone. As you have heard, my name is Albert Lewandowski, and today I would like to share my experience with running the Apache NiFi on Kubernetes, on moving the NiFi from the old on-premise cluster. And I think that I can start with a bit with my background. So I'm mainly working on some DevOps tasks, but also on some data engineering. And I'm mainly specialized currently in the Kubernetes, Google Cloud, and also typical Hadoop clusters. About the content for which I would like to go through, are mainly aspects related directly to the observability about running NiFi on the Kubernetes. That can be quite challenging in most cases, and how to manage all the stuff, especially that the NiFi is quite widely used tool. And especially when we talk about migration from the old clusters to the new one, we can apply a lot of enhancements. So let's start with main use case for which the Apache NiFi was created. So Apache NiFi is a really popular big data processing engine that provides the graphical web user interface. Currently, more and more people talk about the no-code tools, and the NiFi can be also showed can be shown as the example of such tool. Sure, in most cases, NiFi still requires coding, but as you may expect, it can help in significantly reduce the amount of code that must be written. And when we talk about the use cases for the NiFi, why should we use NiFi? So the NiFi is a great tool to manage a lot of ETL pipelines, making stream from batch. So imagine that we have the external SFTP server from which we read files. We read it with the NiFi, then we produce the messages to the Kafka, and then we process all the data with, for example, with the Spark streaming or Apache Flink. NiFi is also a great tool to download files or, for example, read file from HDFS, and based on the content of the files, run the Hive query. And it's also worth mentioning that in some cases, the NiFi was replaced by tools like the Airflow, but Airflow is a great tool for a bit different and simpler things. And why do we even talk about the Kubernetes? NiFi in most cases is run in the clustered mode in the typical bare metal servers or virtual machines, and now we talk about the Kubernetes. So in fact, the NiFi is not designed to be running on the Kubernetes, but as you may expect, a lot of people shared also their experience in the internet. And we also, in one project, we did the migration from the old clustered NiFi to the Kubernetes ones. So the reasons why we decided to go to the Kubernetes is that it simplifies management of the whole NiFi ecosystem, to manage all certificates, configuration files, and all stuff around it. And there is also one important note about it, that the Kubernetes simplifies adding new NiFi instance. But I will cover later also some more complex use cases. And when we talk about running the NiFi, most people are mainly focused only on applying this business logic to the pipelines. But in fact, the business logic is only a smart part of work that must be done, especially in case of running the NiFi on Kubernetes. So the first thing when we talk about the NiFi on Kubernetes, we need to start with the most simple thing. So the NiFi container image. And here you can find a lot of these different opportunities to deploy your target version of the NiFi. But here I would like to present you the one idea that works the best in our cases, because it's the most flexible one, and it works quite typical like Lego toys. So we have the base image of the NiFi that based directly on the official container image that you can find in the NiFi GitHub repository. Then based on this base image, we install the plugins. In our case, there were the plugins for the Apache Ranger and Apache Atlas. And as the last step, so when we have prepared the NiFi with required plugins for all NiFi instances, then we create the dedicated images for each instance. So imagine that we have 4 teams like sales, marketing, data engineering, data science, and each team requires different their own NARs that are used in their pipelines. And if you work with Kubernetes for some years, possibly you heard a lot of about running Java applications in the Kubernetes, and that it's not the best environment for it. But thankfully, the whole IT world is developing pretty fast, and currently it's a pretty okay environment to run any NiFi workload. There is also a possibility to run the NiFi stateless, in which the NiFi does not require storing all of its flow files directly in the storage, but the NiFi stateless has some of its own limitations. So it's great for really simple pipelines in which we have only 2 or 3 steps. It's not great when we talk about the production grade complex pipelines in which we have several process group and in which we need to wait for some results from some external services. That has impacts on some different pipelines. So the NiFi stateless is great when we have the simple use case, but then we can go with also simpler application, like even the Apache Airflow. So the NiFi stateless is a great idea, but I'm not sure if in most data engineering tasks the NiFi stateless makes sense. When we talk about running our Java application, in that case the NiFi on Kubernetes, we need to plan the resource usage. So as the whole story for which we planned, for which we made the migration, we started with the 3 nodes NiFi cluster that works on the bare metal, and we decided to divide them into 5 separate instances. The main reason was due to improve the performance and also to divide all the pipelines for each team, because we started with the really big NiFi cluster in which each team has its own process groups, and finding and going to the most basic component took too much time. So and it was also a great example that we need to do something. So so here we come with the Kubernetes as the solution. So the first thing is about setting up all the JVM settings, because in case of the NiFi, when we use some components, like for example a Hive-free QL processor, there may appear also the memory leaks for which we need to be prepared and we need to monitor. But the monitoring is the last part of my presentation. We need also to estimate how much memory and CPU will be used for each NiFi instance. It really depends on the pipeline, so it requires a lot of meetings, and I would say that these meetings are required to estimate successfully required resources. And one more thing is about the fast storage for NiFi, especially in case of the pipelines in which we process a lot of small files downloaded from the external data sources, and when they are merged or when we do any data engineering tasks directly on the NiFi. And fast storage is not a problem in most cases, but it might be a problem when we talk about the Kubernetes cluster, especially on premise, when we need to find the right solution. So the recommended when we require the best performance is about using the local disks. Unfortunately, the Kubernetes starting from version 1.22 supports pretty easy mounting and unmounting local disks. based on the nodes. The next thing is about the network performance. Based on my experience, in most cases, the NiFi is directly connected with the Hadoop cluster. So we download some data from HDFS, we write the results, we use the Hive, we connect directly with the Spark Kafka. So it's also really important when we make a POC or MVP of our NiFi and Kubernetes to verify if the network performance is enough, if we can improve it in any way. So it requires also some test phase that must be taken under the consideration as the first step. The next thing is about the storage, which I mentioned can be really tough when we talk about running the Kubernetes. In some projects, we have limited resources and we are not able to change the storage. But fortunately, the NiFi can even run quite smoothly with the simplest NFS storage. So it's also quite a valuable experience. But in fact, even if we have limited resources, we can find a solution that will satisfy all requirements from all engineers in our team. When we talk about the migration requires a lot of time, especially when we talk about the instances in which most people do not write any documentation, or in case of the pipelines which are running in the production for several years and they were not upgraded for a long time. So the migration is a great time to optimize and also update all the stuff. Because in each version of the NiFi there appear a lot of great enhancements, and it's an example of the tool, of the open source tool that is developed all the time with a high quality, and it's great that you can see all the time the release notes with a great number of the enhancements, improvements, and the new features that all the committers add to the Apache NiFi. So if you have the older cluster, like for example the NiFi 1.7 or 1.9, when you upgrade to the latest 1.14, then you can also explore new opportunities for your pipelines. So when we talk about the migration, we need to start with absolutely the simplest pipelines. Trust me, then you will discover, for example, some problems with the script, problem with the newer version, or problem with running it on the Kubernetes due to some dependencies that this solution, that the script had. You need also to verify use processors. In some cases, people create their own NARs to customize what they want to do within the NiFi. So it's also pretty important to find the source code of it, and if it's possible, also to make a small refactor or verify what's happening under the hood, and then deploy it as the last layer of our Docker image. In our cases, we also found some used processors to which we weren't able to find the source code. So and it required rewriting some parts of the pipelines. And the last thing is about monitor resources usage. That makes sense, especially with when we start with the simplest pipelines, because it can be used as the base to calculate all the required resources. When we go to the deployment step, here I would like to mention about the Helm chart. Helm is the tool for templating Kubernetes manifest, and it's really useful tool. But in some cases, it may also requires writing a lot of YAMLs. But well, it's 2021 nowadays. Everyone uses and loves YAML because we have to love it. So the Helm chart makes sense because we can create exactly the same templates for all of our NiFis, and then create separate values files in which we can define separate parameters, separate name of the volumes, or an external storages that we want to amount to that exact instance of the NiFi. And here I can also recommend using Helm file as the next step after the Helm. The NiFi is a typical stateful application, so it's not the perfect match for Kubernetes. because Kubernetes is a great match when we talk about the stateless application. But on the other hand, Kubernetes delivers a lot of different advantages that causes that we want to run more and more services on the Kubernetes. So here we need to remember that on the Kubernetes, we have the type of the object that is called stateful set. So it's the most important difference in comparison to the ordinary object of the Kubernetes, well, the most standard one, in comparison to the deployment, is that the stateful set maintains a sticky identity for each of our pods. So it's useful when we want to run the cluster NiFi on the Kubernetes. That is really complex, and that's something what I wouldn't recommend for most cases, that we have all the time the same host names. So imagine that we have the NiFi, NiFi 0, NiFi 1, NiFi 2. Not like with the deployment in which we have the NiFi and the random ID. And the greatest question all the time, so should we run NiFi as the standalone instance or as the clustered one? The cluster NiFi seems to be like a perfect solution, but before we will not verify the true high availability of the NiFi. So in fact, each NiFi instance in our cluster stores some data locally. So in case of any failure of one single instance, then we don't have this data, or we can reprocess them when this exact NiFi instance will be up again. So in fact, the clustered version of the NiFi is not as good as we imagine that it can be, but it's due to the whole architecture of the NiFi. And currently, the clustered NiFi also requires adding the Zookeeper. That is the next stateful Java application. And yes, you can deploy it, you can install it. But here we come to the different solution. That is the single instance NiFi. That is great, especially when we have a lot of teams that use our NiFi cluster, because then we can divide the pipelines for each team, and we can also divide all the resources for each team. So I would say that it would work like a kind of yarn queue manager, but for the NiFi. And it's also the use case that is well suited for Kubernetes world. So in that scenario, we would, and this scenario means also that we can accept that in case of the failure, it will be okay that the NiFi will not consume or produce data, for example, for about 2 minutes. Because if we have to consume and produce data all the time, constantly, then the cluster one is the mandatory option. The next thing is about the certificates. That can be also quite complex when we talk about the NiFi and the authentication layer, because it always requires creating the certificates. But here I have this exact slide. So the NiFi requires using the HTTPS, its key store and trust store to enable authentication. And one of the most important things when we talk mainly about the on-premise clusters, it's really important to be sure that in the trust store we have saved all the required certificates. The perfect solution is the following, in which we have the HashiCorp Vault, and we store as the secrets the key store with certificate to that exact NiFi instance, and the trust store with imported all certificates from our clusters. And that's also the most complex one, because it requires having the HashiCorp Vault. But I would say, well, it's a recommended setup, because using the basic Kubernetes secret is not the most secure, as we have everything stored only as the encoded. But if we want to make the POC or MVP of the NiFi, or if we want to keep it as simple as it's possible, here we go with a bit different tool. So the NiFi from many versions ago, introduced the tool that is called the NiFi toolkit that can be used to create and manage our certificates. So we can dynamically create the certificates via external NiFi deployment, in which we would run only the NiFi toolkit, and then when we start the new NiFi instance, it can access our NiFi toolkit instance and request the certificate. Then the NiFi instance retrieves the certificate, and it can also update its thruster during starting up. But in some cases, it can also mean a really slow boot up process. When we talk about the on-premise world, I must say something about the Kerberos. That is, I suppose, the favorite tool of anyone who has some experience with administration of the Hadoop clusters on the on-premise. So fortunately, running the Kerberos, adding the Kerberos to our NiFi on the Kubernetes is pretty simple. One thing that I, in most cases, recommended is about creating only the headless GitHubs to avoid adding the host names to the GitHub. But when we talk about Kubernetes stateful set, it's also possible, because then we have the kind of static host name. The next thing is about managing access, because everyone loves security, and well, it's required to manage permissions for each users to each pipeline, especially when we talk about the production grade complex pipelines, which are responsible to process a lot of data from different data sources. So Apache Ranger is well known in the Hadoop world. Tool used to manage access, all the permissions to the services, like for example also the Kafka, HDFS, Hive, Spark, Presto SQL, currently known as the Trion. There is also a possibility to connect Ranger with the Trion, and it also supports the tools like Apache Atlas, used for data governance, data lineage, and the Apache NiFi. And for the Apache NiFi, you can find in the internet already compiled the NAR package for the NiFi, and then we can manage all of the policies directly from the Ranger, and it's really useful, and well, it's a must-have in most situations in which we have authentication based on someone's Active Directory credentials, and we manage someone access from one central Ranger. The next thing is about checking the policies, because as I said, the migration process, especially when we talk about the NiFi that works in the production for some years, is a great time to verify all of added policies, and it's also a great time to implement audit features if you need. And well, audit is always a valuable thing in the data related components. About some issues and challenges, it's really important to use one JDK version to build any components or any plugin. It sounds simple, but it can be sometimes forgotten. The next thing is about choosing the right version of the plugin, or even it's also quite reasonable to compile the right version from the source code. And the last issue that we had when we talk about Ranger and connecting it with some NiFi ecosystem is the problem with the no buckets in the NiFi registry with the Ranger. So the NiFi registry is a kind of GitHub or GitLab for NiFi pipelines. And the NiFi registry can also be connected for the Ranger. And there can be also found the issue that doesn't happen with each version, that in the Ranger, you can't set up the policy for the NiFi registry buckets, because there are issues with mapping the users and groups directly from the Active Directory. One of the most challenging thing in the NiFi world is the CI/CD. Previously, when there was no NiFi registry, it was a painful process. Currently, fortunately, we have the NiFi registry that can be used to store and manage all of the CI/CD pipelines. So the NiFi registry, it should be treated like a kind of Git repository for NiFi pipelines, because under the hood, it uses a different structure, and detecting all the changes works in a bit different manner. But it's the tool that can be currently used in the production, especially that we have we have the mature release of the NiFi registry. So the NiFi registry also has its own limitations. It can be really tough during the migration process when we migrate the pipelines from the old version, and where we can find the information, for example, that in the new version we don't have the processor that we use in the old version. So the NiFi registry is great to manage the up-to-date version of the pipelines, but for the migration, it can be quite tough to make a lift and shift. It will not work that way, trust me, because then you can also find some custom processors or the processors that were already replaced by some different. But if we have our target configuration, then it's a great tool, because we can manage we can have the basic version we have the whole pipeline in the NiFi registry, and we have the variables set up for each NiFi instance separately, and then we can easily deploy the latest version of the pipe of the process group to the NiFi, or we can also easily revert the change if we found any bug. So the NiFi registry, it also requires setting up some rules when we talk about directly the development in the NiFi, because NiFi is not NiFi is, as I said before, is the tool that also supports a kind of no code. So it also means that it can be used by so many users, not only developers. About all of the scripts that we use in our NiFi is so here we need to remember that we have two ways of it, or three ways. Well, it depends. So the first thing is about adding the scripts directly to our image. The next one is about using the external storage, and the last one is about gathering the scripts each time from some external source. So it's also widely it can be widely found in a lot of NiFi clusters that some users use their custom scripts that no one knows, and it wasn't in any Git repository. And here we come with the NiFi registry. So it's the another advantage of moving the upgrade or migrate process. And the new environment means also the new challenges. So it's the time when we can update also the documentation, add tests for our NARS or any custom scripts that we use, like for example bash scripts or Groovy scripts. It's also a great time to update security policies, verify which technical users are used in our pipelines, because it can be some of them can be hard-coded, while it shouldn't be, as you may expect. And the last thing is about verifying which external resources are used, like for example, which Kafka cluster, which HDFS, and what is the configuration of them. When we talk about planning all of the actions with the NiFi on the Kubernetes, is about, well, making the divide and conquer, like I called this slide. So about verifying which pipelines we can divide into group, for example, for the marketing, or which group can be used only for making the ingestion to our Kafka cluster, or that can be only used to make only read the data and based on it run the Hive query. So It's also it's a complex process, but we can easily calculate required resources when we start with the small MVP, in which we start with some simple pipelines, because then moving one by one process groups, we can easily detect with, for example, with which exact component we have the problem, like with the memory leaks that happened in our case several times, but fortunately we were able to fix it. And one important thing that is always mentioned in any conference related to the Kubernetes or running anything on Kubernetes is about the whole monitoring and how should we and how we are able to monitor it as we work in the kind of web services world. About, well, the NiFi strengths and weaknesses, especially quite great that can be easily detected, especially when we move it to the Kubernetes, is that the NiFi with its web user interface allows really fast development, and it's pretty easy and fast to rewrite some process, rewrite pipelines, rewrite scripts. But on the other hand, as it's not the tool in which we code, for example, like Spark or Flink, that it has some limitations that cannot be overcome. But in most cases, we can find a solution. It's highly advisable that you can go to the internet and look if anyone does not created a solution which you are looking for, especially in the GitHub issues or in the Cloudera forum. So the NiFi is not the tool that solves all the data engineering, data science world challenges, but on the other hand, it's the tool that can reduce the amount of code, and that's the tool that can be used by people from a lot of different teams. That is also a big advantage, especially when we do not have a complex data engineering team. And about the observability of our pipelines, because, well, it's great. We have already set up everything. We have moved all of the resources, and we want to verify if our pipelines works as expected, if they consume the right number of events, all the things around it. So we need to start with the most basic thing, that is the monitoring directly the resources and monitoring all the Kubernetes things. In case of the NiFi, the most crucial thing is about monitoring the CPU and memory usage, and it's it's required to set up quite wisely the limits for CPU and the memory, especially that the NiFi can consume as much memory as it has, like some Java applications. Especially when we talk about the NiFi on which we are running a lot of resources that requires a lot of read and write actions. So it's required to have the monitoring, and here starting from 1.10 version, Apache NiFi delivers a great client to expose all the metrics. So the default metrics from the NiFi, they can be easily exposed by the client that is already built in the latest releases of the NiFi. While we have some custom metrics, or we want to add additional metrics, then we can push our metrics to the Prometheus push gateway. I mentioned the Prometheus as it's mature open source solution that you can easily install on any environment, and you can find a lot of great tutorials how to deploy it and how to set it up in the right way. But Prometheus has some of its own limitations, I would say. So the one thing is about adding the service discovery. In case of the NiFi, it can be easily done by adding each NiFi with its publicly, I mean here within the company, known host name. And we can add such NiFi as the static target for the Prometheus. But on the other hand, we can also provide the service discovery, and then we need only to add the information to the annotation of the NiFi pod. And about the logs analytics, because I think I don't have time to go into details about only the Prometheus for NiFi. So the next thing is about the logs analytics. So gathering logs when we talk about the observability is a must-have. We can easily detect if there are any issues with processing events, or if there are any issues with, for example, writing files directly to the HDFS. Unfortunately, in many cases, the NiFi and NiFi registry does not deliver logs from which we can easily find of any issues. But on the other hand, especially in the last releases, I saw a great improvement. So here, it's really recommended to install any tool that supports logs gathering, like Elastic, the whole Elastic Stack, or for example, Grafana Loki with Promtail. That is the another great open source solution from the, I would say, Prometheus ecosystem. And the one important thing when we talk about running the NiFi on the Kubernetes is about adding the sidecars that can be used directly to tail logs from each container. So we can define that the one sidecar tails the logs about the users, the second one tails logs about the current from the current uplog file, while the last one only reads the information about the NiFi server. So about the tools, well, I would say that the Grafana Loki is a great tool when we talk about the tool only for the IT team, which wants to create all the alerts directly in the Grafana, and they are looking for something that can run smoothly on a small amount of resources. While you need also to have the tool that will be used for business, or you want to have the tool that supports running the complex query for the last, for example, for days, and you want to make a count or find distinct events, then the Elasticsearch makes a lot of sense, especially that there are a lot of differences from the architecture point of view between the Elastic and the Loki. And about lessons learned after the whole migration, currently we are running 5 NiFi instances as the single in the target Kubernetes environment. Well, I created some important questions that must be answered before starting the whole journey. So does Kubernetes really add the value? In our case, it makes sense to manage all the stuff not with the Ansible or with any different automation tool, but by running, but by setting everything with Helm charts, and especially that we receive the great amount of the resources on the Kubernetes. And here we comes to the second question. So how big Kubernetes do we currently have? Because it doesn't make sense when we have available only one node on which we can use up to 4 CPU and, for example, 10 gigabytes of memory, and on which we do not have set up any storage, because it's required for the it's required for the NiFi to have some resources. And the last question is about, do I have experience with Kubernetes? If you want to start your journey with Kubernetes, with migrating the NiFi to the Kubernetes, well, it's a bad choice, because running NiFi on Kubernetes requires some previous experience directly with the Kubernetes, with its, well, I wouldn't say the limitations, but the specific the specific tasks that must be done on the Kubernetes, and how it works under the hood, how the Kubernetes schedules all the pods, and how some health checks works in this world. So it makes sense to start with something different, not with running the NiFi on the Kubernetes. Well, I would say that running Spark or Flink is much simpler in comparison to the NiFi. The next thing is about verifying what we really need. The first thing is about having the secured setup or not. It also depends, because we can add some limitations in terms of the access, for example, by using the ingress, in which we would have the authentication proxy or anything like this, and then anyone who can pass these proxy can access the NiFi. So it's absolutely the simplest setup, and, well, honestly, in most cases, it's required to have the Ranger, and we've turned on all of the security setup. The next thing is about counting the required CPU and RAM. Because the NiFi, when we talk about the thing, without having a small fleet of NiFi instances, it will consume much more resources in comparison to the cluster one when we sum up all of the CPU and memory, because NiFi uses also great amount of resources when it doesn't do anything. And the difference between these two worlds, so the cluster one and having the fleet of NiFi, can become greater and greater when we move more and more resources. The next question is about having the cluster versus single node setup, and here we go back again to the questions about requirement from our side about processing data, and if we can afford the situation in which we cannot consume the data for 2 or 3 minutes. The next thing is about having the registry, but in 99% of the situations, it's required to have the NiFi registry, and I can also recommend it as the right tool to be sure that we have everywhere the up-to-date version of the pipeline, and that in case of any failure of the NiFi, we can easily redeploy the NiFi with the latest version of the pipeline. The next thing is about categorizing the pipelines. So defining which pipeline are used for each team, and what are the dependencies between each pipeline, because it's also the next important thing. So finding the dependencies between different pipelines and how they consume data and how they depend on each other. And the last thing is about also monitoring the required write-read disk performance. So the NiFi on the Kubernetes, in fact, is still an undiscovered world, and I suppose that it will be better and better solution on running on the Kubernetes. And managing all CI/CD aspects can be pretty tough. But in fact, when you will have everything set up, then developing anything on the NiFi in the development environment, then deploy the change to the staging and production, then it will be, well, a kind of piece of cake. So it's worth spending time on it. And the last thing is also about exposing application to the users, because as the NiFi has, when we decided to use the secured version, it verifies as the first step the certificate from the users. If the users doesn't provide any certificate, then it asks for the, for example, Active Directory credentials. So here we can use the tools, like for example, using the Metal LB as the load balancer and then expose directly the service with the Apache NiFi, or we can also go with some different solutions. So imagine that we have the F5 big IP ingress controller, and the administrators of the clusters decided that we must use their own certificate, but to not have the conflict with the NiFi, we need to decrypt the traffic, then route the traffic from this F5 big IP controller to the instance on which we are running a small web services, for example, written or Node.js or any different language, and then we can contact the NiFi when we encrypt the traffic once again based on the right certificate. So I think that's all for today's presentation, and I would like also to recommend recommend reading some articles that you can find in the Getting Data blog, in which we also talked more about some NiFi scripted components and all the pain points and advantages of the NiFi. And I would like also to recommend you to join us, because we are looking constantly for people who wants to work with the big data solution. So, well, I think that the time is up, so it's 44 minutes. So yeah, thank you for your attention. So it's time for questions and answers if there are any questions.
Thanks a lot, Albert, for your great talk. This was definitely, at least for me, a part of the Apache stack that I wasn't too familiar with. You are a little just before the time is up, and no one has come forward with any questions yet. So maybe I would just encourage people to reach out to you either
That's
through
right.
the
So
conference.
yeah, you can drop me the message via email or LinkedIn. Well, I'm available online all the time. So yeah, if you have any questions, well, I suppose that I can help you. So yeah.
Thanks again so much for being part of the
Thank you.
conference and for your talk. And
Have a good day. Bye
enjoy the
bye.
rest of the conference.